Good afternoon, everybody. My name is Gianluca Corbellini. I am the CEO and co-founder of Hive Power. We're building software to enable automated flexibility management in energy communities, but also in other use cases. Everybody in this room has been affected by the huge increase in energy prices happened last year. And even if right now we are seeing that the prices are going back to more normal levels, to lower levels, the intraday volatility is here to stay. And this is mainly driven by the increasing penetration of renewables. Moreover, we see that two of the big sectors of our economy are now merging. So the power sector and the mobility sector are basically going together. And this is mainly driven by the power sector, which is in need of a lot of flexibility, again, because the increasing penetration of renewable is causing this unbalancing between production and demand. And the other side, the national regulations and also people want to adopt electric vehicles. So these two sectors are creating a new whole ecosystem, which is becoming extremely important, but also extremely complex. And the energy transition we are facing, we are trying to reach net zero soon, is again extremely complex, as we have been hearing in the past two panels that explain that very well. And we think that this complexity also comes from the numbers of stakeholders involved in these processes. So if we go bottom up, we can start from the consumers or EV drivers or prosumers, and then we have their energy retailers, energy service companies implementing energy efficiency, and then we have grid operators like the DSOs, TSOs, or other players like the aggregators, which are typically aggregating flexibility and then marketing it on different markets. So the ecosystem is extremely complex, and the solution towards net zero will not be driven by a single technology like EV or PV or batteries. It will be a combination of a lot of different assets, a lot of different software optimization tool, and so on. And this is where we are playing. So with Hive Power, we are developing software to basically putting together all these stakeholders in this smart flexibility management. And another part of this strategy to reach net zero soon is given by energy communities. So energy communities are basically a grouping, local grouping of users in the same area. That could be a single building, like a condominium, or a district. So people living in the same, basically, streets or part of cities. And the main idea is that there are national incentive programs across Europe, basically driven by European policies, where there are incentives to share local renewable energies. So the main goal, again, is to synchronize the demand of energy with the local production, which will be mainly solar, but could be also small wind or hydropower plants, but also biomass. And two very important consequences of these new schemes are that they enable, in a kind of implicit way, the optimal allocation of renewables. So, for example, if in a district there is no solar plant, there's a big incentive economically to build new ones. Or if there is already enough or even too much, there's not such an incentive to build another plant. And the second very important consequence is the push for the electrification of the demand. So electrification of demand is another extremely important aspect of the energy transition. And of course, here we're talking about mobility with electric vehicles, but also heating through heat pumps. So if we manage also to synchronize the demand of energy from those two main kind of assets, of course, the economic benefit can be higher. And let's look like what an energy community looks like. This is our first project that we started already 5 years ago in Switzerland, close to Lugano, where our company is based. And basically, you can see you have a set of single-family houses, some of them with solar rooftop. Then we have a kindergarten with a district battery, a lot of heat pumps, and EV charging stations. And being Switzerland, a very electrified country, a lot of houses, they already have a lot of power available at their plug, like easily 11 or 22 kilowatt each house. There's a lot of room for this flexibility management. So we also manage in this first pilot project, started again 5 years ago, the optimal operation of heat pumps, EV charging stations, and also the district battery. And it was not only driven by a single, let's say, single user self-consumptions, but also for the community behavior, and also for the DSO benefit. So in this project, we also included peak shaving for the DSO. After this project, we have been managing several communities, kind of 100 between Switzerland and Italy. And so the key aspect in this energy community is smart optimization was the flexibility management. So what we mean with flexibility is all those assets that you can steer in time in their demand without affecting the comfort of the end users. So we definitely think that the two main players will be stationary batteries for sure, but also EV charging in the near future, also with vehicle-to-grid applications, but also like thermal stuff like heat pumps or air conditioning or domestic hot water heaters, but also smart appliances. Smart appliances, they don't have so much consumption per asset, but they are everywhere. So you can steer quite easily already today wet appliances like dishwasher or washing machine or tumbler dryers. And also in this case, we have a partnership with the biggest appliances manufacturer in the world and testing this also inside energy communities. So the three main advantages you can bring with flexibility management is, of course, reducing the cost for the end users, improving the economic performance of the energy retailers or energy traders that then can give indirectly a benefit to the end users. And also the very important aspect is also on the infrastructure. So you can improve the performance of electric grids. I would like now to focus more on the electric mobility side. So this is a thing that we're studying by several years across Europe, and I would start from three things that I think we already learned for sure. So EV charging will increase the demand of energy, but not really in a crazy way. We will find a way to produce that amount of energy. So how is not really the big question. The big question is more when. So when we will charge the vehicles during time. So technically, we see that it's not really an energy issue, but more a kind of power issue. And the second given fact today is that EV charging, also vehicle-to-grid, could be already very important flexibility providers for the infrastructure, but also for energy markets. There are already several pilots everywhere, basically in the world, that proven this technology to be able to provide very good results and also very fast, even within 1 second to provide the desired power. So basically we can consider electric vehicles from the power perspective like just batteries on wheels. Then there are three main questions that we always face when we talk to new customers or new stakeholders in general, or even like to normal people on the streets. First of all, how much is the value that we can extract from a battery electric vehicles in different scenarios? Or the consequent question is, which are the enabling variables to improve this value that we can extract with smart charging or vehicle to everything? And the third is more a kind of technical question. So is this new behavior of the battery really affecting the lifetime of the battery in the vehicles? So is the state of health effectively accelerating its degradation in time because you have different profile? And of course, I don't want to bring just questions. I can bring already some answers. We see with what we call smart charging, so monodirectional optimization of charging, we can be between 200 and 500 euros per car per year, depending on the scenario, country, regulation, prices. And then we can even reach 400 to 1,000 euros if we go bidirectional and addressing several use cases together. And this is true for passenger cars. If you go to more heavier vehicles like buses and trucks, these numbers can increase dramatically, even reaching 10,000 euros per year per truck. And then in the second question, we saw that the amount of solar generation, of course, the volatility in the national energy market is very important, and also the access to balancing markets. If we have these three things together, we can definitely go to the upper bound of the ranges shown in the previous line. And the third question is still a bit debated. If you have let's say, a small car, the effect could be seen, could be quite important. So in that case, typically the automaker will limit how much you can do vehicle-to-grid during a year. But then with bigger vehicles, like with premium cars, there are already cars in the market which are warranties for 500,000 kilometers. So you have space to do also vehicle-to-grid at the same time. And let's go back to what flexibility means and how we can market this and reach those amount of value in money. So there are basically different ways to address flexibility. We'll start from the left side, so with a behind-the-meter application, and then we can go to the infrastructure. today it's easier in some countries like Switzerland, the UK, and so on, to market flexibility for the TSOs, for the ancillary services. But then everywhere, I think today the big thing is price arbitrage on the energy market. So basically you can delay your charging, the charging of your vehicle when the energy is cheaper on the energy market. Or if you can do vehicle to grid in a bidirectional manner, in some countries like Italy, for example, they already allow you to charge and discharge your vehicle just doing basically paying the commodity price when you charge the vehicle. So you can already really leverage the battery of the vehicle already today. The DSO thing is something that maybe is a little bit more in the future because the regulation is not there yet in many countries, but it will be also extremely important soon. In Switzerland, which has quite a different regulation also for the DSOs, we already tested and we're already using it in a commercial way. So we start more for the first use case is what's happening behind the meter. So it's called typically implicit demand response. And in this case, you can store solar energy with your stationary batteries or vehicle for a later use, typically at the dinner time when prices are higher. Or you can do peak shaving if you're like a big user, a big consumer. In some countries, you also pay for your monthly peak. So peak shaving is another interesting cost reduction use case. Or in general, you can do load shifting following the time of use profile that you face as an end user. The last one is maybe the low-hanging fruit, but it's quite limited. Because if you think about residential users, you typically have a very simple time of use profile, which is day and night. But the difference between day and night is pretty small, typically. It's not a big incentive. And still, you face the same price for many hours in a row. So this is not really so interesting. What we see right now that is very interesting everywhere, we have pilots ongoing and starting in different countries across Europe about this, is the day-ahead optimization. So price arbitrage, especially with stationary batteries and EV charging. So you can basically play for the BRP or indirectly for the energy retailer to optimize charging and discharging, if possible, of vehicles against hourly energy prices. And we saw, like last week, we saw a crazy situation, like in the Netherlands, where for 2 hours in a row, the price was minus 200 euros per megawatt hour. But still, this is like a crazy situation, but I think will not be that crazy in a few years. It will be very common. As long as we don't have enough storage, the volatility will just increase a lot. And the third use case is about ancillary services. So basically, what we are doing there is enabling large fleets of distributed assets, again, mainly storage and EV, but also other kind of assets, to be aggregated and then marketed for ancillary services for the TSOs. So again, here the challenge is that in some countries this is not possible at all today, but in Switzerland it's already doable, and we're also testing it with one of the major car manufacturer. Another advantage of EVs and storage batteries is that they can be extremely fast in providing the power needed. So there are already several pilots across Europe that prove that within 1 second they can reach the target power needed. So allowing them to participate in very interesting new capacity market. So what we want to really deliver and what we think is really the future that we need to reach the energy transition as soon as possible is putting all together all these use cases and also all together all these different kind of assets. So we think that software will definitely play a key role in this situation. Hardware is needed, but I think hardware that we have today is already capable to be steered in time and be controlled. And that's what we're doing. So very happy to be here today. We have a booth downstairs if you want to discuss further. And of course, we are very open for collaborations in pilot or commercial projects. And also we are fundraising, so open to talking to investors. Thank you.